depending on the technology that we use and also the medium for the transmission, we have different data link layer transmission protocols and also technologies, basically. In this case, IEEE 802.11 defines the standards, or standardizes the way how we communicate through wireless local area networks. Wireless local area network basically refers to Wi-Fi. It's the Wi-Fi that we also use in our homes. It implies using a certain frequency range, and of course, as the name suggests, is done wirelessly. We notice here that again the logical link control and the higher layers are the same regardless of the type of technology that we communicate, whether it's Ethernet or wireless LAN. However, in the MAC layer, 802.11 defines exactly the way how we should transmit the messages and the details of these messages for the wireless LAN. There are different type of standards depending also on the characteristics of the physical medium that we use and also on the type of speed that we can provide. Here we see that Wi-Fi from its earlier version, Wi-Fi 1, up to the latest version, which is Wi-Fi 6, that there is significant differences in the maximum link rate that can be provided, but also each of these refers to a specific definition by the 802.11 working group. Of course, there are also some differences in the frequencies that are used, depending also on the maximum link rate that we can provide. When we talk about the wireless LAN, we need to also define what is the network structure. We define the basic service set and the extended service set. Basically, the basic service set implies having some mobile stations that communicate with one another, like having a classroom in which we can send messages from one equipment, from one device to another device. In fact, these equipment are connected through the APs, which are basically the access points, and are known as ad hoc networks because the equipment which are part of this network might change over time. Considering again a limited space, a classroom, there might be equipment which leave, or people that leave or come in the classroom. Hence, the network itself can be identified as an ad hoc network. The extended service set implies that different of these basic service sets are connected through one another through a distributed system. Distributed system denoted as DS here, and is basically showing that there are 1, 2, and 3 basic service sets that can also be communicate through one another. They can send information from one side to the other through its corresponding access point, and might use also a different means of communication. In this case, they can use a wired communication to connect with one another. Now, the basic service set, when we talk about the basic service set, the stations or the equipment which are present in the network are controlled by this coordination function. What does this mean is that it allows to coordinate the way how the communication is handled between different equipment. And also here the architecture might differ depending on the type of the basic service set that we identify. In particular, we can identify the infrastructure BSS or the independent BSS. What in practice this means is that in case of the infrastructure BSS, we have a centralized interconnection. This means that there are a set of equipment which communicate between one another through a centralized entity. In this case, it can be an access point, and also the name, the centralized interconnection, exactly refers to the type of architecture that we see. On the other hand, when we talk about an independent basic service set, the idea is that it is possible that a set of equipment, a set of stations, communicate with one another independently without the need to go through a centralized entity. And as mentioned before, the extended service set implies the interconnection between different basic service sets through a distributed system, which can be a connection in a local area network through Ethernet and so on, that allows the exchange of information from one access point to another access point. In fact, when we talk about the distributed system, we don't necessarily mean that the connection should be a wired connection. In fact, it can be also a wireless distribution system in which the corresponding access points in the basic service set communicate with one another through the wireless domain or through the wireless transmission media. All of these different technologies that we have considered, all the different standards which are defined, and also the architectures which are defined, since we are referring to the data link layer, also imply a certain set of rules, standards, in order to do error recovery. This is particularly important because the type of medium that we use, in fact, is very noisy. It is possible that there are several equipment that are transmitting at the same time. So in fact, there is an essential need to implement mechanisms that allow for error recovery. In fact, the way how error recovery is handled is through positive acknowledgements, the same way in the stop and wait paradigm that we have seen in the transport layer. The access to the physical medium. So there is a strong relation between the data link layer and the way how the access to the physical medium is handled. The main mechanism that allows to manage the access to the physical medium is defined as the carrier sense multiple access with collision avoidance. So this implies that allowing several stations, equipment to connect to the same, to use the same transmission medium, while aiming to avoid any collisions in the use of the medium. And this is done by doing or implementing a set of functions. One of these functions is also the distributed coordination function that we will see with an example. The idea is that before initiating a transmission, a station, an equipment, will listen to the channel for a given time, which is identified as DIFS. And if in this time the station or the channel is free, then the station will initiate the transmission. If the channel is busy, then there are mechanisms that are put in place in order to ensure that the collision does not happen. And in fact, in case the channel is busy, then the station will enter a phase which we identify as collision avoidance through use of a random backoff in order to wait for its turn before starting the transmission. Let's look at a simple example of three stations, stations A, B, and C. Station A is transmitting. At a given moment in time, station B will want to transmit. However, it checks that the channel is in fact busy. We said that before you initiate to transmit, what happens is that you need to wait for a certain amount of time. This amount of time is in fact equal to the DIFS, which we have defined in the previous slide, plus back-off time. The back-off time basically refers to a randomly chosen number of slots before you initiate the transmission. And if the channel is free by this amount of time equal to the DIFS plus the backoff, then station B can initiate the transmission. In fact, if the channel becomes occupied during the backoff as we see in the case of the station C, which has checked if the channel is available and has gotten the message that the channel is in fact busy. If during the back-off period of channel C, of the channel, and during the back-off period corresponding to the station C, it is noticed that the channel has become busy, then the back-off countdown will stop, and it will resume when the channel becomes free. Exactly the moment that the channel becomes free, then the remaining back-off will again be considered. So this mechanism of collision avoidance allows the use of physical medium, or for example in the case of wireless communication, in order to enable the different stations, as in this example station A, B, and C, do not transmit at the exact same time, and hence avoiding the collision of information sent from one station and the other. The same way how we have identified the frame format, because since we are in the data link layer, we still refer to the frames. Same way how we have identified it for the Ethernet, we define it also for the wireless LAN. The logic is more or less the same, so there are 4 addresses per frame. It is important to mention that now, since we are referring to the data link layer, again, the data link layer ID or identifier is the MAC address. The only difference now is that there are 4 addresses, because you might be dealing with scenarios in which you also have to know the address of the access point of the basic service set that we have defined before. Then there are other identifiers, such as the sequence number or the duration or even frame control, which perform more or less the same set of tasks as we have defined in the previous case of the Ethernet. When we talk about the physical medium, there are also messages which pertain exactly to the physical layer, and the 2 main ones are the preamble and the header. Preamble basically serves for doing synchronization on the receiving side, whereas the header contains some information on the transmission rate, on the payload of the physical layer, and doing some error checking functionalities and so on. When we talk about wireless, there are different technologies that are implemented, and each of these technologies, for what concerns the physical layer, might vary or differ from one another. For example, 802.11b implies the use of 2.4 gigahertz channels, whereas the one on 802.11a implies that the band that is used is at 5 gigahertz and so on. And the same also for the G and ACU. You see that there might be similarities between the different type of protocols that are defined in order to ensure that the communication when we use the wireless local area networks is as efficient as possible.